Go over some homework in a little bit. Takes you back. Ah, good. 1 over cosine squared x, right? From first semester. So, actually, don't do that up there. What's the antiderivative of 1 over cosine squared x? Yeah, don't stop there. We'll see how you do. Did everyone do all right with that? Yeah. All right, we'll see how you do. Hey, it's a rule. Actually, I'm a little more lenient on the quiz. Give you partial credit. One more. This one's going to be hard. Oh, thanks. Someone does. We don't. We could find out. I don't know what we're going to do. It is exciting. We're pretty excited. That's a weird function. Don't really run across that every day. Negative ln the absolute value of cosine x. What's the rule for natural log? So 1 over cosine x, but don't forget to times negative sine x. No, derivative. Derivatives, not antiderivatives. Derivatives. So that gives me sine over cosine, which we know as tangent. So that gives us another rule.
Cosine was negative sine?
It is. It is.
It's a negative cosine already. So wouldn't it be just positive sine?
No, the negative's out in front. The derivative of cosine is negative sine. Look, this negative's out in front. If you want to put it in the numerator, you can. If you want to put it in the denominator, you can. Or you can just put it out in front. I chose to put the negative in the numerator so that negative 1 times negative sine x is positive sine x. All right. So this is another rule, which you were going to confuse with the rule we just did. The antiderivative of tangent x. The antiderivative, of 1 over cosine squared is tangent x, but the antiderivative of tangent is not 1 over cosine squared x. Yeah. Keep going, Gabby. Don't stop. Great. That's why we did that, right? I had you take the derivative and said, oh, isn't that weird? You get this simple function. So it's the antiderivative of tangent. It's that sort of crazy function. Yep. Do you see how you're going to get them mixed up?
Yeah.
You're going to confuse them. All right, so the first one, 1 over cosine squared x dx, is actually from the first semester. We're just undoing something that we already learned. The second one, I don't think anyone would have figured out unless we looked at the derivative of negative ln of cosine of x, and that's not something you would maybe think to do. Not something I would think to do. Someone else thought of that, and I was like, oh, I'll show them. Okay? All right, 2 more rules. We good?
Wait, why are you... Now, isn't that a product rule, though? If you're doing negative ln multiplied by the absolute value?
That's not a product.
Oh, because
okay.
You're doing ln of a number, and a number is a function. It's like chain rule.
Yes, that's exactly what it is. It's a composite function, and that's what this represents, the chain. That's absolutely right. Okay? Is that all right?
Yes.
Okay. All right. More on undoing the chain rule. So that was well-timed, Asa. Couldn't have picked a better time to say that. All right. Let's see what we can do. You ready for like a million examples? Say yes. All right. That should keep us busy for a little bit. All right. Who wants to take a shot at it? It's hard. It's not easy. Will? Courage for the deed?
The first one, sign, or negative sign, 1/2 or 1/3 t.
What about the t?
You ignore it.
Yeah.
All right, so if I were to take the derivative of a negative sign, what would the derivative of negative sign be? Negative cosine of that. And then you would chain on No, you'd chain on the derivative of what's inside here. What's the derivative of 1/3 t cubed? 1 t squared. Not going to work. Courage for the D, though. It's a nice try, right? But so that gives us a few hints. I think we can use that a little bit. Betsy?
Well, if you look at the tan x equals negative ln cosine x, it's kind of similar.
Okay.
So would it be negative ln of cosine t squared?
Cosine t squared. So if I took the derivative of the ln function, the natural log function, the derivative would be 1 over cosine t squared. And then I have to chain on the derivative of cosine t squared. No, of cosine t squared. What's
negative sine squared?
Yeah, negative sine t squared is the derivative of that. And then the chain, yeah, that's not going to work. Jack?
Yesterday, didn't we do something like, can't we like add a 2 on one side?
Okay, so I know what you mean, but don't say add, because you don't actually mean add.
When we multiply a 2.
Okay, so we could actually put a 2 here.
Yeah, and then for the opposite, we have to do 1/2 also.
Alright, so if we put 2t, what does that make 2t? What does this represent now?
The chain.
That's the chain. So once you have the chain, we can forget about it. Alright, so sounds like not a bad start. We have the chain now.
Okay.
So what's the antiderivative of cosine?
Sine. Cosine would be t squared.
Multiplied by 1 t third, t to the third.
Is it 1? It's 1/2. Just 1/2.
So I need the 1/2. I can't forget that the 1/2's there. Do I need anything else?
No.
Can I just do plus c or?
Plus the, yeah.
Well, let's think about it. If I took the derivative of sine, the derivative of sine is cosine t squared, but don't forget to chain on a 2t, but 1/2 times 2 is 1, so it's t cosine t squared dt. Oh, sorry, cosine t squared. That worked. See how hard that is? Yeah. So the first part's recognizing the chain, and the second is thinking about the chain backward. What's the inner and outer function? In this case, once you have the chain, we're taking the antiderivative of the outer function, which is cosine. What's the derivative of the antiderivative of the outer function? Sine. We don't have to worry about the inner function because we have the chain. 2t is already there. So I get to sort of make the chain and then forget about the chain. That's the beauty of it. All right, let's take a look here. This one might be a little easier. I'm not sure. Jack calling someone. Cosine 3 minus t plus c. So the antiderivative of sine should be, but, Derek?
You have to chain on the derivative of 3 minus t, which is
Ah.
-1.
If you took the derivative of cosine, you'd get negative sine, 3 minus t, but then you'd have to chain on the derivative of 3 minus t, which is -1. Good. Yeah, go ahead. Betsy?
Well, this is I just forget. Is it sine goes to negative cosine and cosine goes to sine?
The antiderivative of sine is negative cosine.
Oh, right.
Okay.
Because the derivative of cosine is negative sine.
Yeah.
Sorry.
Okay. All right, Derek, calling someone for 3.
Is that an 8?
Yeah, that is an 8. Sorry. Where'd the 1/2 come from? So what we really need is a 2 to make the chain. You can't put 2 unless you have the 1/2. So that's where the 1/2 came from. Zach's missing a little something. Do you see what you're missing?
Times the 1/2 by.
No.
Oh.
Isn't 1
No, it has to be. The 9 has to equal 1/2. 9 times what equals?
Yeah, so should it be 1/18?
9 times what equals 1?
So look, you just keep the 1/2's there regardless. Now you have to anti-differentiate change. Right. Well, okay, so 1/9, which is going to be 1/18. But if you're taking the antiderivative of something to the 8th, it's 1/9 something to the 9th. Now, if you want, sure, you can simplify and say 1/18 x squared plus 5 to the 9th. Okay? Good. That was nice. Ooh. Gabby? You sure? 4, courage for the deed. I've heard from you. Tali, courage for the deed? You don't have to say yes. I was just asking.
No, thank you.
You sure?
Yeah.
Kaylee?
Well, I'm just not going to actually do it.
All right, go ahead. Say it.
Okay. That is the same thing as saying 4 minus x to the 1/2.
All right, so 4 minus x to the 1/2.
Negative 1.
Sorry. Liz, you want to pick it up? Gabby?
I actually have a question.
Okay.
Is it like 1 over like anything like the ln or something?
Ah.
Am I like doing that backwards?
No. There is a rule for 1 over a function being the natural log. However, that's 1 over a function to the first power. So the problem is if we had 1 over x plus 1 to the first, and we tried to take the antiderivative, we would say, oh, that's x plus 1 to the negative first. And when we increase the exponent by 1, we get 0. Then we divide by 0. So that's our clue that, oh, that rule doesn't work. We need the natural log. So for this function, the antiderivative would be the natural log of x plus 1 plus c. However, this isn't raised to the negative 1 power. This is to the negative 1/2 power. So if it's any power other than negative 1, we can use the power rule, the opposite of the power rule. Do you want to take a shot at it?
Would it be,
Are you sure? I'll wait. No? All right. Asa?
1/2 multiplied by it would be negative 1/2 multiplied by 4 minus x plus c.
4 minus x raised.
4 minus x to the 1/2.
All right.
Plus the no cigar.
All right, so we have a couple things going on here. I do agree. Look, you took 4 minus x and you increased the exponent by 1.
Yeah.
What's the rule after you increase the exponent by 1?
Take it down.
No, not
No.
take it down.
Times by
You would
what
divide by the exponent.
Okay,
so
so
then you multiply by 2, so it's negative 4 minus x plus 2.
I thought you were.
No, if you
What
divide by
times,
1/2.
what times 1/2 equals what?
Sorry. So there's a 1 right here.
Yeah,
There's
what
nothing
times
there.
1/2 equals?
And so now you need to divide by 1/2, so you're going to get 2. Well, all right, so let's talk about
Chain on the
You
negative.
turn on a negative 1.
why do we need the negative?
You turn on a negative 1.
Oh, okay, because
Oh.
the derivative of 4 minus x is negative 1, so we do need that negative out in front. It is. It's very tricky. And the thing is, the more you see, the more you can be like, okay, I've seen something like that. I have an idea of where to go. It really is. It's about exposure more than anything else. That's why we're going to do 15 more today. Woohoo! Do you want to ask a question before we do another couple?
Do children like that?
I don't know.
What? You said?
I was just wondering.
You can't ask that question. Because I don't like it. There are 24 of you and 1 of me, and if I was asked that question 24 times a day, I'd go crazy.
Come on, let's play through this one.
You can't self-nominate yourself to be spokesperson.
I know this sounds like but I was wondering, do your kids actually like
Everyone hasn't even seen the Earth yet.
No, but I mean, like, I was just wondering if like you work with them on that.
I really don't. Like, if they have questions on their homework, I help them. But like,
They're just like.
I don't need to. Yeah, I don't need them to do anything more than what they like.
Your ESC
7 and 9.
Because he said it earlier about the those were
They are very excited. I had to tell them to stop saying names because I just said names for like an hour straight. I said write them down. Like I can't take it anymore. All right, we've gone from easy and medium to medium and hard. Okay, these are hard. Uh-huh. All right. Asa, who's up?
Whoever wants to be up.
Oh, come on. Do better than that.
Let's start off.
Yeah, we can open the door. All right. Sorry. What do you got?
1/3 x to the third times. Okay, so in order to get that, it's definitely going to be e to the 1/4 of x to the 4th plus x, but I'm not done yet. I'm still thinking.
Yeah, because if we were actually doing this to find the derivative, what's the first thing you do?
Chain 3x.
No, if we were trying to take the derivative of this, you would do what rule? Product rule. You do the first times the derivative of the second plus the second times the derivative of the first. Does this look like the result of a product rule? No way. So it's not the result of a product rule.
Oh.
Hold on. Courage for the deep. Go ahead, stay with it.
So then it's got to be chain. Yeah.
All right, so one is the chain of the other. Which one's the chain?
X squared, X to the chain, or plus X to the third. This one's got me.
Tolly?
I mean, I'm probably wrong, but e to the x cubed plus 1, I think, is in the initial equation, and because you're taking the chain rule of that thingy,
Yep.
the thing on top, exponent, so that's x, that would be 2x, a 3x squared.
Okay.
So you'd need to multiply times 1/3.
Yep.
Would it be 1/3?
Okay.
Hold on.
Oh,
Plus c. And again, you can check. The derivative is going to be 1/3 e to the x cubed plus 1, but don't forget to chain on a 3x squared. The 1/3 times 3 gives you the x squared. That's good. Hey, you're starting to get it. All right, next two are a little tricky. I think after we do the first one, the second one won't be bad. Or after we do the second one, the third one won't be bad. I don't know what I'm trying to say. Zach? Okay. So this is the chain of that. So we have to divide by the new exponent. And then I think we're off just by a very little bit.
If the chain, if it was the chain, it would be 1/2 cosine 3t to the negative 1, right?
No, the chain would be the derivative of what's in the parentheses.
Yeah.
What's the derivative?
So 3.
Okay, so we're missing a double chain, which would be a 3. But I can't just write a 3 there unless I put a 1/3. So I'd have to multiply this by 1/3. So I get negative 2/9 cosine 3t to the 3/2 plus c. And is the...
Where does the 2/3 come from again?
So
because cosine 3t,
Oh, right,
that's
right.
1/2. Get that.
So you increase, so this is actually, as much as we see a trig function, this is actually the power rule. It's something to the 1/2. The antiderivative of something 1/2 is something to the 3/2 and then times 2/3. I'm going to ask a question on that one. That was hard. All right, you guys are doing a great job. I'm impressed.
quick question?
Yeah.
So for any of the 1/3 is my question.
So Betsy was saying that the derivative of cosine of 3t is the sine of 3t.
It would be negative sign.
All right, sorry, negative sine of 3t, and that means you need a negative out here.
Okay.
But you just chain on the 3.
And then the derivative of 3t is 3. 3 is actually a double chain.
Okay.
And so that's where the 1/3 comes from. Wait, did we do okay with our negative signs here? Is it going to be negative 2/9 or positive 2/9? Because you're going to chain on negative sign. Yeah, okay, we're fine with our negative signs. See how much thought and care goes into this? This is like for careful people. It's an alpha. Just an angle. Not being very flexible. All right, so what do we have here? This should be sort of similar. Kayla, you want to take a shot at this one? It's like same sort of pattern. Nope. Liz?
But it'd be negative cos.
Liz, are you okay with the fact that Gabby just swiped it from you? Are you sure? Oh, you said no? I didn't hear you. Sorry. All right, Gabby.
Negative cos
Cosine squared cubed?
No, cosine.
Okay.
And then times 1/9.
So if we had to take the derivative of this, what's the first thing we'd have to do? What rule? Product rule, and then the quotient rule within that. Does this look like the derivative of a product rule? Mm-mm. Not a bad thought. And there's going to be a lot of this, like checking and then working your way back. Betsy?
Is cosine the chain?
It is. If it helps, this guy's actually thinking, I am sine alpha cubed, right? All right. What do you have?
So then it's negative cosine.
I don't think so.
Is it like 1/4
Keep going, Liz.
cosine thing alpha 4.
So it's the power rule, right? 4 times 1/4 is 1. Sine to the third. Don't forget to chain on cosine.
So the 3's outside the parentheses.
Yeah, so these are just different ways of writing the same thing, right?
But you don't have to chain on it. There's only one chain. I mean,
There's only
something-
one chain,
Yeah.
which is cosine. Is that all right?
And wait, why would you not have the cosine included? Like, where's that included?
The cosine is the chain. Take the derivative of this. 4 times 1/4 is 1. Decrease the exponent by 1. Sine cubed theta. But don't forget, chain on the derivative of what's inside. That's cosine.
Okay.
So, do you see how it's sort of like a puzzle, and the biggest piece of the puzzle is recognizing which is the chain?
Mm-hmm.
Like, you have to figure out, oh, is one the chain of the other? It's hard. All right, last one for today. This one's very hard. Zach? Oops, sorry.
Should we simplify? Should we simplify the first part? Since e to the t times, no?
Oh,
Yeah, you can't count that.
But we're just
This
simplifying.
example was on our
what?
This example was on our
No, it actually
I got
wasn't.
an idea.
You did,
That's what I did
but
on my
not. This is not the same, and it's this strategy is not going to work. Okay, well, I think it was on your homework from the first section, so. Yay.
And I asked Jack, can I ask you about today? How
For,
to do fractions?
Yeah.
didn't I show you?
Yeah, but it was only worked for that one problem.
So we really need to recognize one of these. Like, there's nothing algebraically that's going to be all that helpful. There is something, though, that's a relationship between the numerator and the denominator.
Isn't the numerator the chain of the denominator?
It is. So I have 1 over e to the t plus t times e to the t plus 1, where this is the chain. Once I have the chain, I can forget about it. So the question is, I have 1 over something, Gabby. What's the antiderivative of 1 over something? Yep. And let's try to take the derivative. The derivative of the natural log of e to the t plus t is going to be 1 over e to the t plus t. But don't forget to chain on plus 1. Yeah, that works. Nice work, Gabby.
One more time.
Because you can't take the natural log of a negative number, so that absolute value is really there to remind you that you can't put values of t that are going to make that negative. That would be bad. Okay?
One more time.
All right.